So good afternoon everybody, myself Acharya Vishvendra. Let's discuss a question based on force time graph. So force is given as a function of time over here. Mass is 2 kg, initial velocity 10 meter per second. First is you need to find initial force. As you can see in the graph that initial force corresponds to 20 Newton. Then force at t is equal to 5 second. So you can see that at 5 second force is equal to 200 Newton, 20 Newton sorry. Then we need to find force at t is equal to 7 seconds. So as we can see in the graph, at t is equal to 7 seconds, force is 0. Next is force at t is equal to 6 seconds. So 6 will be somewhere lying in between here. So we can think like this. We can make a bigger triangle like this. So here this thing is 20 like this, and this thing is 2 over here, 2. And if there is 6 over here, then this thing will be 1 as given in the graph over here. So this point corresponds to 6 seconds. So this difference will be 1, and we assume that corresponding to 6 second force is y. So in the bigger triangle we can say that 20 by 2 is equal to 10 theta, and in the smaller triangle it is equal to y by 1, which gives that y is equal to 10, or force is equal to 10 Newton. Next question is we need to find impulse during 0 to 5. So we know that impulse is integration ft, which is area under ft graph with sign, and we can see that till 0 to 5 this shape is a rectangle. So its area will be 20 into 5, which is 100 Newton second. Next is we need to find velocity at t is equal to 5. So using impulse momentum theorem, impulse is equal to change in momentum, which is mv minus u. Impulse we have calculated as 100, so this is twice of v minus 10, which gives v minus 10 as 50, which gives v is equal to 60. Next question is impulse during 5 second to 7 second. Similarly, we can use impulse momentum theorem. Impulse is integration of ft, which is area of the ft graph, and you can see that from 5 second to 7 second this graph has a shape of a triangle, and we know that area of triangle is half into base into altitude, so that will give the impulse as 20 Newton second. Next we need to find velocity at t is equal to 7 seconds. So we know that impulse is change in momentum. So total impulse till 7 second is 100 plus 20. This 100 corresponds to 5 second till 5 second, and 20 second during 5 second to 7 second. So using this, so we get v as 70 meter per second. Next we need to find average force during 0 to 5. So average force is impulse upon delta t. Impulse during 0 to 5 is 100, time is 5, so we get average force as 20 Newton. Next is average acceleration. So force is mass average acceleration. Using this we get average acceleration as 10 meter per second square. Then we need to find average force during 5 seconds to 7 seconds. So average force delta p by delta t. So during 5 to 7 change in momentum is 20, delta t is 2, so the average force comes out to be 10 Newton. Next is we need to find average acceleration during this. So force average is ma, so we get a as 5 meter per second square. Next is at what time total impulse is 0. So we consider that at t time impulse is 0. So this thing is gonna be t minus 7. So impulse is change in momentum, impulse is 0, so upper moment impulse will be positive, downward will be negative. And if it is 0, then we can say that upper momentum upper impulse is 120, lower is minus, so we have used minus sign over here, and it will make a triangle, the area being half into base into altitude. So using this we can say that y as a function of t is 10 into t minus 7. So using this we have 240 is equal to this gives t minus 7 whole square 24, which gives t minus 7 as root 24. So t is gonna be 7 plus root 24. Root 24 is approximately 4.9, so that gives t approximately as 11.9 second. Next question is force at t tending to infinity. As you can see on the graph that at t tends to infinity, force will tend to minus infinity, and force is mass into acceleration, so acceleration will also tend to minus infinity. So these videos are especially designed to develop your problem solving skills, and it includes multiple concepts, starting from very simple question and tending to very heavy questions. So these can be used for preparing physics for your school exams, for NEET and JEE Main especially. So I hope it will prove to be optimization tool for you. Thank you and have a nice day.